Well, hello everybody. Here we have our circuit. What has it got? Well, it's got 4 rows of resistors, each one 80 ohms. So here's resistors in series, but all the different rows are connected along the top and the bottom, and they are in parallel. Now there's something very interesting about the voltage of resistors like this. I'm connecting in our battery. Let's have a look what the voltage is going to be across the terminals. So here's the red one, and you see that our voltage reads 5.74 volts. But it's 5.74 there, and there. The voltage is the same. Likewise on the bottom here. Everywhere along that wire, this wire, that wire, this wire here, where there's no resistance, the voltage is the same. The voltage only begins to drop across, well, it actually, if here's 5.7, it'll drop across each resistor and we'll get a different voltage. But all the way along the top and all the way along the bottom, in other words, at the top and bottom, where the resistors in parallel join, it's always the same voltage across resistors in parallel. Remember that, very important. It's always the same voltage across resistors in parallel because there is no resistor separating where they join. And where there's no resistor, there's no change in voltage. We have got a whole lot of 180 ohm resistors. Now look at the way they are arranged. There's 2 in series, 1, 2, 3 in series, 4 and 5 in series. But then they in turn are joined at the top. So they are arranged in parallel. So if you were given something like this in the exam, would you be able to find the equivalent resistance of all of those resistors combined? Now, how would you do it? Take a moment to think about it. Well, what do you do when you have resistors in series, 180 and 180? Well, what do you think you do? You just add them. So there's 2 times 180, 3 times 180, 4 times 180, 5 times 180. And you can substitute in your mind that there is, in fact, 900 ohms, which is 5 times 180, or 360 ohms there. So you just add those up and you imagine you just got 1, 2, 3, 4 resistors now. So we've already simplified this problem down to 4 resistors in parallel. And then we have a formula for working out what is the resistance in parallel. So before we do that and work out the calculation, why don't we take our multimeter and let's turn it to, you see there where it says 200 ohms. Now, I already know that when you have resistors in parallel, that's 180 plus 180 is 360. I know that the total resistance of all of them is going to be, or the equivalent resistance is going to be less than the smallest one. So I know my answer is less than 360. So there is the equivalent resistance of all of them. About 141 it says now, 140. Okay, are we ready to do the calculation? And there is our formula. 1 upon R parallel total is 1 upon R1, 1 upon R2, 1 upon R3, 1 upon R4, when those are the different chains of resistors. Then have a look what we did here. 2 times 180, 3 times 180, 4 times 180, 5 times 180. There, we've worked them out. We get our answer is 7,13 times 10 to the minus 3, but we must remember that was working out 1 upon R parallel, but we want R parallel, so we've got to invert this answer, and there we get 140,26 ohms, and that is as close as anything to what we measured on our multimeter.